Proportions in similar figures is an application of what you did yesterday of solving proportions. So the target is that I will find missing links in similar figures and use similar figures when measuring indirectly. So remember back to 7th grade doing the vocabulary, that similar figures, they have the same shape but different sizes, and there are two key facts about similar figures. First, that their corresponding angles are congruent. So take a look at these two triangles. Their base angles, these are isosceles, so they have congruent base angles. On the large triangle, they're both 70 degrees. On the smaller triangle, the corresponding angles, the base angles, are also 70 degrees. The top angle, the vertex, is 40 on the large triangle, and it's also 40 on the smaller triangle. So it doesn't matter how much I enlarge or shrink these triangles, their angle measures are going to stay the same. They're going to be congruent. However, their corresponding sides are proportional. So they're not congruent, but when you compare them with a ratio, they are proportional. So on the larger triangle, the sides, the longer sides are 4 centimeters, the base is 2. On the smaller triangle, it's exactly half that. So the larger sides are 2 and the base side is 1. So you can write these with a proportion to show that they're equivalent. Now you can look at it and see that they're half of it, but they're not always going to be that crystal clear. So the long side over the base on the large triangle, so this ratio is representing the large triangle, is equivalent to the longer side over the base side on the small triangle. I know that these are proportional because I can see that you're dividing by 2, or I can think with their cross products that 4 times 1 is 4 and 2 times 2 is 4. So here are some different pairs of shapes. So let's figure out which pairs are similar and then why or why not are they similar. So think back to our two key facts. Their corresponding angles are congruent and their corresponding sides are proportional. So I think it's easier to pick out the ones that have that are not that are not similar figures. The first one that is not is this set of rectangles. If you'll look, you have their bases there are the same length, but their heights are not. They're both rectangles, but they are not proportional. So they have congruent angles, but their sides are not proportional. Also, this one right here. See how their angles are not proportional. This side right here is an acute angle, but over here it is an obtuse angle. And those are not proportional because they do not have congruent angles. The rest of these are similar figures. They have the same angle measures, but you can tell that they've been enlarged. The same thing here. This one has been rotated, but yet it's still similar. It's been shrunk down. The same thing here. It's been rotated maybe a little bit, but they are still similar. Now these here, they are congruent figures. By nature of being congruent, that means they are also similar figures. So now let's practice this. So let's find the missing number for each set of similar figures. So they're telling you they're similar. So that means that their angles are congruent and their sides are proportional. The corresponding sides that we have are 16 and 8. You can probably look at it and see that that is half of it, or that the smaller measurements have been doubled. So let's pretend like that's not quite so easy. Set it up as a proportion. Notice that they have 3 and x on top. Those are the small sides. So I have the small side on top of 16 and 8, which is the large side. Now looking at the ratios, 3 and 8 is showing the little rectangle, and x and 16 are representing the, and actually it's not a rectangle, is it? It's a parallelogram. My pen can't quite keep up with my writing. There we go. Almost. Just too fast for it. Okay, setting up the ratio correctly is going to be your biggest obstacle. I'm not sorry, the ratio, but the proportion, setting it up correctly. Notice that on top I have the small sides and the long sides on the bottom, and then the first ratio is representing the little parallelogram, and the one on the right is representing the big parallelogram. I could have swapped those around. I could have written that as 8 over 3 is equal to 16 over x. That would still end up being proportional. I could have also written it as 3 over x equals 8 over 16. That is also okay because I have 3 and x are corresponding and 8 and 16 are corresponding, and I still would end up with the correct answer, which is 6. So going with the proportion that they set up, I'm going to cross multiply. 3 times 16 is 48 and 8 times x is 8x. Therefore, x is 6 inches. Let's look at another example. So here we have a pentagon, and we're wanting to find the missing number for each set of similar figures. I have the sides over here, 6 and 1.5 on the smaller one. And so for the diagonal, I'm wanting to know its measure. It is corresponding to this side here, which is 1 foot. So I'm going to start by setting up a proportion. We have x, which is the unknown, over 6. So the diagonal over the side is equal to 1 the diagonal over 1.5 the side. To solve this, we're going to cross multiply. 1.5 times x is equal to 6 times 1, which is 6. Undo multiplying by 1.5 by dividing by 1.5 on both sides, and you end up with 4.